All right, so with functions, we talked about what a relation is, what a function is. Each x value has exactly one y value. You can't use two different y values or it doesn't pass the function test. Highlight, circle, whatever you want to do, vertical line test. That's the main thing you want to know from that. In a function, x is known as several different things. One is the domain, or the input of the function. Y is the range, or the output. You can sometimes, I don't know why I wrote that a second time there, you can call the x the independent variable, where the y is the dependent variable. You often see those names as well. Okay? So then we should know or remember that the domain is defined as the set of all possible x values for which an equation is defined. Okay? Therefore, even though you can't really see it at the bottom of my screen there, the range is the set of all possible y values for a given relation. Now, last year, there are two ways to write domains and ranges. You did two different ways last year. We are going to stick with one way this year, assuming that you know both. We're just going to stick with the more common one that is used in calculus. So we've kind of moved to that. So what you see here, okay, is what we call interval notation. Do we remember this kind of thing? You say that the x is defined between 3 and 5. That's one way to do inequalities. Interval notation, rather than being in inequalities with x's, intervals are with parentheses or brackets, where the brackets mean the same thing as the less than or the greater than or equal to ones, and the parentheses mean less than or greater than. So, to review just this kind of notation before we actually have to find it on a graph. If I tell you in that inequality, the x's are defined strictly between 3 and 5, that translates in interval notation to bracket, because of this equal to sign, 3, comma, 5, ends with a bracket because of that equal to sign, right? What would be the difference on the next one? It would just be parentheses rather than brackets. Now, the only thing that can be slightly confusing with this notation is if they're both parentheses, what does that look a whole lot like? An ordered pair, XY coordinate, right? So you need to make sure that you know what you're talking about with that, or like know that I am referring to domain. You should just read carefully. If I give you something like that, it will have to say the domain is defined as parentheses 3, comma 5, something like that. So it will say the word domain or input or independent variable. It won't just be hanging out there with no context. If the next one says x is strictly greater than 5, how do we write that? On the low end, the x value is starting at what number? 5. Bracket or parentheses? Bracket. Okay. If it is just greater than 5, where does it continue out to? Infinity. Now, anyone remember which of those we always use? Parentheses, because you can't actually get to infinity. It is not ever something you can fully reach that number or get to that number. So we have to use a parentheses anytime we use an infinity. The only difference on the next one would be we also start with a parentheses. And you can mix the two like you see in that middle one and on this last one. How would you write this last one? Parentheses 3, comma, 5, bracket. Is this something we remember from last year? Yeah? All right. Before we get into just a couple more definitions on the back, remember function notation? F of x means the same thing as y. Y equals, right? That's the same as g of x, h of x, any other letter of x, okay? And we literally pronounce that as f of x, like that, right? But f of x is the same thing as the y value. You're going to see a lot of that notation here. literally the main point of it is to name it correctly when you have multiple functions. So what you're going to see this chapter is I could say f of x is equal to blah, blah, blah. G of x is equal to something else, and so on. And then I could say take 2 times f of x. And you know exactly which function that you're talking about. Whereas if they were all y equals, I'd be like, well, the first one. And if you wrote it in the different order, you know, there's no way to distinguish between y equals this, y equals this, y equals this. It's a naming thing, really. All right, on the back. Let's take a moment to practice domain and range. Remember, for domain, you do have to name this in specific order. You have to go for domain. It is always left to right on the graph because it's smaller numbers to larger numbers, right? We have to go left to right. For range, how do you look for that? You go from the bottom of the graph to the top. All right, so for my domain on this one, if I follow that graph all the way to the left-hand side, I see an arrow. What does that arrow mean? It keeps going and going and going and going, which means my domain is going to start in notation as what? Negative infinity. Good. So my domain starts with a parentheses and a negative infinity, and then I follow my graph all the way to the right-hand side. All the way on the right, it does end at a particular point. All right, where is that point and what is its value that we're going to use? 7. We use the x value, right? Not the y. Now, range on this one can trick some people on the range. If you're going bottom to top, okay, often we want to simply say, there's the bottom. Why is that wrong? Because that arrow does what? Keeps going, right? So where does my range start? Negative infinity. Follow it all the way to the top. What's the highest y value this graph gets to? 4 with a bracket. Good. Any issues with that? How do you tell if something's a function? Vertical line test. Remember, the vertical line test basically just says I can draw vertical lines everywhere on my graph and not hit 2 points on the same vertical line. If that is true, then yes, this is a function, right? Now, while we're still at this graph, looking at the same graph, let's talk quickly about a one-to-one function. A one-to-one function, we said a function itself is a relation where each x value has exactly one y value. A one-to-one function is a function in which each y value has exactly one x value. Okay, that flips the definition of function around, right? But what I also want you to note is it says a one-to-one function is a what first? It is a function first. So let me ask you a question. If something does not pass the vertical line test, is it going to be a one-to-one function? No, if it's not a function, it can't be a one-to-one function, right? So the one-to-one function, the test works exactly the same way the vertical line test does. We just call it the horizontal line test. And it works exactly the same way. So if I'm looking at that picture directly above, we are asking ourselves the question, can I draw horizontal lines everywhere and not hit more than 1 point? No. So this is an example of a function that is not one-to-one, right? Okay. There are not very many one-to-one functions. For example, a quadratic is a function, not one-to-one, because the u is going to make it come back across itself horizontally, right? Linear, it would be. Cubic, so on. We'll look at a bunch of these when we look at the parent functions next class. Okay? I am not going to take the time to write out definitions for x-intercepts and y-intercepts. One would hope we know what those are at this point. Increasing. We talk about whether functions are increasing, decreasing, or constant, and then we're going to get a little practice with this on the next page, and I'm going to be done talking about definitions. If a function is increasing, there's a lovely technical definition for this. It is going up from left to right if it is increasing. That is easier to remember than the technical definition. If it's decreasing, it is going down from left to right. And if it's constant, it is what? Flat. Horizontal. Okay? You will remember that much easier than you will the technical definitions. All right? On the next page, here's what I would like for you to do. Since a lot of this is review, I would like you to work at your tables and see exactly what you can answer on this page about that graph. One thing I do want to point out is for questions 12, 13, and 14, increasing, decreasing, constant. We didn't do any like that yet, so I do want you to give them a try, but they are x intervals, which means they are written almost exactly like the domain is. The domain, you say the x goes from here to here. When you say the interval is increasing, decreasing, constant, you also use x values only and use the bracket notation for that. All right? So see what you can do with your tables real quick. So of the ones we have, any questions? Yep.
It was an open circle there. It would be the two separate.
For which one?
For number 2.
For number 2, yes. If there was an open circle, there would be 2 sections to your domain, and you would have to skip with the U. Yes. I do not care. You can, absolutely. You may always put ordered pairs. You don't have to. Absolutely. All right, any other questions over the ones that I have here before we talk about the other ones?
Wait, you don't care if you write it like as an ordered pair?
I don't. Nope. All right, let's talk 12, 13, 14 quickly, and then we're going to come back to 8. So increasing, we said, literally reading the graph left to right, the graph is going up from left to right. So that, to me, breaks that graph that you've been given into 3 sections, right? Because if you're following the graph from left to right, it goes which way first? Up or down? Down. Then it changes directions and goes up, and then it changes directions and goes down. So for increasing, how many sections of the graph are increasing? 1. That section starts where? 1.1. We use the x values and goes to where? 6. Now, one thing I want to talk about on this is my notation. I have used parentheses for these, okay? Your connection to this right now is physics if you're doing this. In calculus later, it's the same connection. There is a split second at a maximum or a minimum that the graph is constant. We are not going to write that as an interval on this for the constant one. I'm not going to worry about that for constant intervals. I'm just saying it's not increasing at that point in time. So that's why I show parentheses at 1.1 and 6, because at both of those places, it has stopped increasing. Decreasing, there are 2 sections for this. Where does the first decreasing section start? -4. It goes to where? 1.1, and then it picks back up at 6 and goes to? All right, and what do we use in the middle? The union, U symbol. I always do it, but I guess it really doesn't matter. Yes?
Wait, why is the 1.1 on there not a bracket?
Because at a split second at that minimum, it's not decreasing anymore or increasing.
Do that anytime.
Split second, it's constant.
Do you do the union anytime you have 2?
Yes.
So like
Union
2
anytime you have 2 sections, and for increasing, decreasing, I always do parentheses. Shh. All right, questions on 12 and 13? Yep, always.
So from it, if you're like given it and you can't tell if it's just an open or closed circle,
Right. Yes. Now, constant intervals are the one place you could see brackets. Shh. Because it would start and be constant at a maximum or a minimum. So brackets could be possible on constant. But this one, basically all you're looking at here is there anywhere that this graph is flat? No. So for this one, we can say none and A. The only thing that's wrong to do is put like 0, because then you're telling me it's constant at 0, right? All right, now, 8. I come back to 8 because every time this is the harder question. Again, you guys have had more practice with this than other years, so it's great. What is this asking me? Where is the y greater than 0? In physical terms of that graph, they're asking me which sections of the graph are where or what? Above the x-axis. That's all it's asking me for. Where are the y values greater than 0? So this is physically looking at that graph, and I'm just going to scroll and show you. It's going to literally be the sections of the graph that are above the y-axis. Those sections. If it was less than, it would be the sections that are below the y-axis or below whatever that horizontal line number is. So in this case, we also have to be careful of notation. And it is because of this notation right here in the question. They only want the values where it is above 0, not equal to. So when I write the x values for that first highlighted purple section, where is my interval going to start and with what symbol? Parentheses what? -4. These are still written with x values. Parentheses -4. Continue on to what x value? -2. What symbol? Parentheses. I understand that -2 is a closed dot, but it wants specifically greater than 0. If you include -2, you're also including equal to 0. And that's not what that circled part is having me do. So then the next section, I'm going to pick up where? 4 and go to 8. Use your union symbol to show that it is both sections. Okay? Is this feeling pretty familiar to us other than a few notation things? Yeah? All right, we're going to do one more of these together, talk maxes and mins very briefly, and I will be done. So, again, with your tables, fly through the next page, same type of thing. I want you to be very, very, very careful with domain and range on this one. Any guesses why? Open dot, closed dot, breaks in the graph, etc. Be very careful. All right, so after checking these answers, real briefly flip over to maxes and mins. We are not going to do this whole thing because we're not talking transformations today. This is more of a notation thing, and this showed up on your test. Shh. Okay? What we have in here, we are going to talk about something that is called extreme maxima, minima versus local. Okay, this is something you're going to see if you go into calculus. On that exact function that I've given you there, if I asked you for the maximum, well, what would you want to tell me? What does that arrow mean? Keeps going up to infinity, right? That is what we call the extreme maxima and minima, the actual maximum and minimum values. Within the graph picture that we see here, we also have what we call local minimums and maximums. Local is where it changes direction from increasing to decreasing. In other words, right here at the top of this hill, I would say that is a local maximum. Okay? It's not the maximum of the graph, no, but it changes from increasing to decreasing. It's the top of a hill, so we call it a local maxima. Maximum, one. Maxima is plural. Local minimum, then, for us would be right there, right? We use those every time. Yes, ma'am?
Could you please send Jack to the front? He's leaving.
Yes, ma'am. We use those every time we identify increasing and decreasing intervals, right? So, for example, just like we were doing on the previous page, where is this graph increasing, or where does it start increasing? From negative infinity up to an x value of where does it stop increasing? Negative 2. Picks back up, increasing at what x value? 3, and goes out to infinity. Okay? Decreasing is a single section between negative 2 to 3, right? So the reason we identify these points as local maximum and minimum is because we are, for example, increasing to the left of x equals negative 2 and decreasing to the right. Therefore, we have a local maximum. Now, there are 2 questions that you will be asked, and this confuses people every year. Where is the max or min? This is asking for an x. What is the max or min value is asking for the y. Okay? Knowing that difference is rather important. So, for example, this one has a maximum at x equals negative 2. What is the maximum value of that is asking for the y value at negative 2, which in this case is 4. Works the same way for minimums, except if it's decreasing to the left.
You have to say like x equals 1.
No, you do not. You could just say the minimum of the function at 3 is 0.
And you're always referring in those questions to local?
Yes. I will always be referring to local. The only place I'm ever going to want to see the pure max and pure min is going to be the domain.
Wait, is the extreme? Wait, when you said pure,
Pure or extreme, yeah.
would that be like? Is it the highest point of where it changes direction, or would it be like infinity?
If it's extreme, I'm asking like for this one, the minimum itself would be negative infinity and the maximum would be positive infinity, like the extreme ones, yes. In these kind of questions, I'm always going to say, it's always going to be referring to the local, even if I don't say it. Okay. So very briefly again on that second one below. This one again, if it goes out of the graph, we know that the actual minimum here would be continuing on to negative infinity. And this is practice with that notation or the language of this. When it says at what values does it have a maximum, what is it asking me for there? Careful. I know it says what in it, but it's asking for a location here, not what is the maximum value, right? It's saying at what value does it have a maximum. This is asking for an x, okay? What are the maxima, or what's the value? Okay, that's the y. I don't care about justifying. Okay? So in this case, how many maximums does this technically have if we're talking just about locals? 2. It has 1 at x equals negative 7 and 1 at positive 7. At both of those, it has the same maximum value, which is 3. Even if one of those hills was higher than the other, you would still tell me that there are 2 maximums. Okay, because our definition of a maximum in this particular set of like what we're talking about, the functions, is where it changes from increasing to decreasing, right? So even if one hill is higher than the other, there's still 2 maximums, right? This one has a minimum at only one location. What X value does that have? 0, right? What is the minimum value? -4. And just for extra practice, what would the domain be? -infinity to infinity. Good, because it goes out to either side, keeps on going. Range on this one would be what? 2 what? 3 with a bracket. Good. Learning the language of the maximum and minimum is the not hardest thing, but it's just you have to think about it. So, homework for this is the following 3 pages. Not that page right there, but these. Functions, we're going to do everything from 1 through 11, I believe. Everything 1 through 11. On the maximum and minimum page, this one, we're going to cut off after question 8. Okay? On the maximum minimum page, which is page what here? I don't know. 105. Page 105. We're going to cut off at 8. All right?